Here's a bit of practice following the previous video and PowerPoint on piecewise functions. These come from the textbook, so you can pick them up there. And I have put the video portal links as well there, which you can use in the PowerPoint if you wish to. Let's have a look at the first piecewise function. Now, we're just drawing these ones. So the first thing we need to decide on is the critical values. Or we could draw the graphs first, I guess, but let's do critical values. X equals 0, x equals 1, there we are, x equals 0 on the y-axis and x equals 1. I don't need to label every single point if I've labeled the axes, so it's very clear that that's at 1. They're the light graphs. Absolute value of x, y equals x squared, the blue, and y equals 2x plus 1, the green. I'll do it this time, working out the excluded points, but hereafter I'm not going to do it until we actually draw the segments of the graphs. It's often easier doing it at that stage. Having a look here, x is less than 1 for x squared, and x is greater than 1, 2x plus 1. So both of these are excluded from x equals 1. So let's just slot that in like that. Now, there we are. We have the green graph to the right of x equals 1. We have the blue graph, there it is there, between the two. And then we have the red graph, the absolute value of x, to the left. So there is our piecewise function drawn as a graph. Let's have a look at number 3. First of all, critical values. -2, -2, -2, 0, 0. So therefore, -2 and 0 are the two critical values. Drawing in the graph slightly, well, this is y equals 0, which is the x-axis. This is the point, -2, -1. So there we are, -2, -1. There's the absolute value graph. It's the graph it's the graph absolute value of x, y equals absolute value of x. Then steeper because of the 2 shifted 1 to the left and down 2. So there we are. There it is there. And y equals -x. Let's now have a look and see. We have that graph, the y equals -x, to the right of x equals 0. We have the absolute value graph between the two critical values. And we have the red graph less than -2 to the left side of that critical value. So there are our graphs. I put an exclusion sign there. You need to show the exclusion there because these two graphs join there, and if you don't put an open dot there, then it means you're implying that that point is included. Here's fun, because we have greater than or equal to 0, so it is part of y equals -x. Number 4, there are critical values 1, 1, 2, 2, so 1 and 2, and our critical values, our light graphs, y equals x squared plus 2, there it is there, y equals 2 to the x, that one, and y equals minus 2x plus 8, there we are there. The green to the right, so therefore y equals minus 2x plus 8 to the right. The red, which is this one, the exponential graph, so therefore the exponential graph between and the parabola to the left. So there we are. There's a shift there, there's a break there. That's not included because on the parabola x is less than 1. And there's a break there too because on the exponential graph x is greater than 1. and x is less than 2, so therefore we have that, and that's greater than 2, x greater than 2. So we have 3 indications, open dots, showing that those points aren't included. Number 5, there are critical values, -2, -2, -2, 1, 1, so therefore -2 and 1. Let's draw the graphs lightly on there. If x is less than -2, it's y equals 2. So there's y equals 2 going across there. If x is -2, y is 1. So there's the point, -2, 1. Y equals x squared between -2 and 1. So there's y equals x squared minus 1. And then if x is greater than 1, we have y equals -1. So there's y equals -1. The green graph, x squared minus 1, is between the two critical values. The red graph is to the left there of the critical value, y equals 2, and y equals -1 is to the right of this critical value because x is greater than 1. So there are graphs, once again indicating this graph, y equals 2, does not occur when x is -2, just to the left. So therefore we need an open dot there. Y equals x squared minus 1, -2 less than x, so we need an open dot on it. And there's the dot indicating the point, -2, 1. And then on the right-hand side, because x squared minus 1 is less than or equal to 1, we have a closed dot there. And finally, we have y equals -1. It's only greater than 1, so we have to exclude the point at x equal to 1. Sorry, x greater than 1. So there we are. One of the aspects of it, finding the values of functions. So consider this function. There it is, quite an extreme function with 7 different segments. Without actually sketching the function, determine the following. So, g of -4, all we have to do is look and say, well, -4 is in this section here, -3 is in this section here. Therefore, g of -4 and g of -3 both have y equals x plus 3. What we're going to do is substitute -4 into x plus 3 and -3 into x plus 3. Next one, g of -1. Well, it's at -1 there, so it's going to be this one, and it's going to be equal to 4. G of 0, that's well within that region there, so we have x squared plus 1. And g of 1 is also within that region, so therefore g of 1 also has x squared plus 1. There we are, g of 0, g of 1, both are within there, so we substitute 0 into there, and we substitute 1 into there. Next one, g of 2. We have a problem with g of 2 because if we have a look there, x squared plus 1 is only for less than 2, and 11 minus 3x is only for greater than 2, so we have the function not defined at 2, so therefore we can say it does not exist. G of 2.5 falls inside between 2 and 3, therefore we have 11 minus 3x for g of 2.5. Substitute 2.5 into there, and we get minus 4.5. G of 3, well, that's when x is equal to 3, and the y value is 1, so therefore equal to 1. G of 4 fits in there. Between 3 and 6, 4 does, so therefore you're going to have x minus 4 for g of 4. So therefore g of 4 is x minus 4, 4 minus 4, 0. G of 5 also fits into that area. So therefore we'll have 5 minus 4 equals 1 as well. 11, G of 6, well, it's not included for x minus 4. It's not included for y equals 2. So there's another one that does not exist. And number 12, G of 7, that's well within the region greater than 6. Therefore, y equals 2. And therefore, we're going to have G of 7 equals 2.